Hello everyone and welcome to my new video. Today we are going metal. Not this metal, but this metal. In this tutorial I will show you how to create a procedural material in Blender, and without any further ado, let's get to it. So select the default cube and now let's modify it a little bit. I actually didn't intend this to be a modeling tutorial, so I will skip the explanation of the modeling part. But it's really simple, just few extrudes and insets and then bunch of loop cuts. So for the moment, just use a box and bevel the edges on it, or add Suzanne, for example. It's a good model to view the applied materials. So let's rotate her a bit, scale it down. Okay. Now add the subdivision surface modifier and set shade smooth. Okay, now we will set up our scene. In the world tab, let's select the environment texture and open the default Blender folder, which is Blender Foundation. I'm using version 3.4, the data files, studio lights, world, and I will use the sunrise texture. Let's select the light now and set it to sun and set the strength to 10. Okay. And finally, let's go to the render tab and select cycles as our preferred renderer. The material will work with Eevee as well, but we'll get to that later. So the prep work is done, and now let's go to the shading tab. Let's center the view a bit on the models, select the models, and choose our material for both of them, and let's name it procedural bronze. So first, let's create some masks. We will use a node called geometry that returns information on our object, and we will use the pointiness socket and connect it to a color ramp to increase the contrast of the output. So let's plug it into the base color, and now if we move the sliders, we don't see anything meaningful happening. That is actually because the pointiness doesn't work in Eevee. It's cycles only, and since we are all in a preview mode, we will not see the effect of it. But if we switch to the rendered view and start to play with the sliders, we will be able to see the result. Okay, so let's set it up to 0.477, the white one, and the black one slider will be on 0.505. Okay, this will be our crevices mask. So now let's copy the two nodes. Okay, and let's also change the sliders. The white one will be, or first move the black one, which will be at 0.536, and the white one will be at 0.491. Okay, so this will be our edge mask. So let's actually frame it, and let's name it a edge mask. And let's also frame the other two nodes, and let's name it crevices mask. Okay. You may wonder why we didn't invert the actually invert the sliders. Why we stayed the same and just adjusted the contrast. That's because later on we will actually want the mask to be black on the edges, and for some usage we will invert it. But for the moment we need it like this, and we can actually move the edge mask aside for the moment, and we'll use that later on. Now let's make some noise. So add a noise texture Nice. Okay. Let's duplicate it. Control C, Control V. Let's also add a texture coordinate node. And let's plug the object socket into the vector socket. Now to combine or to blend these two noises, we will use a mix node. We'll set it to color and the mode will be multiply. So let's connect the factor of the top noise into the A socket and the factor of the bottom noise to the B socket. Let's also plug actually the result into the base color to see what it looks like. And now let's set the values. So the scale of the top one will be 4, detail will be 6, roughness we will set to 0.663, distortion to 0.1. The other one will be scaled a bit differently. It will be 15, detail will be 3, roughness 0.922, and the distortion will be the same as 0.1. So this will be our noise texture, and we will drive with it pretty much everything from the material. So let's also organize it a bit. Let's change it. Let's frame it, and let's name the group as base noise. Now we will make a base color for our clean metal. So let's change the metallic to 1, roughness to zero point 0.1, and let's separate the noise from the base color. What we will do is we will use a color ramp to colorize the base node. So let's plug the result into a color ramp. Okay, and we will use a black and white color ramp that we will drive into a HSV node, which is hue saturation value, and we will not drive the hue but the value with the black and white color ramp. So let's plug it into the base color. And why we are doing it is because actually later on we can expose the single color to a group input node, and we can change a single color actually and have achieve different results. Now let's set the color to our bronze, which will be 0.8 on the red, 0.517 on the green, and 0.305 on the blue. So this is our base color, and now let's adjust the color ramp to bring out a bit the details of the noise. So we will move the first slider bit and set. Actually, we will only set the value. So let's set the value to 0.685 and adjust the position to 0.014. Let's add one more stop. Set the position to 0.162. The value here will be 0.698. Okay. Additional one, position 0.289, value 0.5. Another one at 0.441 with a value of 0.599. Okay, this one is at 0.704 and the value is 0.648, and last one is at 0.817 and the value is 0.673. So let's also move this one to 0.986, and this is the setup for our color ramp. for our base color of the clean bronze. This doesn't need to be too contrasty. It just adds a bit of just a little bit of a variation to the base color. So this is nice and clean, but we will darken the color of the metal in the inside of the crevices, and this is actually where our crevices mask will come into play. So let's add another color ramp and use the crevices mask. So let's move it. Let's move it to the side. Let's move it somewhere here. Let's plug the output into the color ramp, and let's move this to the side. Let's add a mix node. Set it to color. Plug the base color into slot A, the color ramp into slot B, set the mode to multiply, and let's set the value actually to 1. And now let's check for a mask what it does. It does nothing because we don't have it plugged into the base color. So let's see. Okay, so actually, what it does is it creates the bronze, only the base color along the crevices. That means that the mask is inverted. So if we flip the sliders, we will have actually the mask in a correct way. So let's play around a bit with the sliders to tune it to our liking. Okay. I think something like this is pretty much what we want. Okay, so this will be at maximum, and actually we will be driving the factor later on with a single parameter, and we will be changing it from 0 to 1 as the material ages. So let's keep it at 0.5 at the moment, and let's also add additional hue saturation value node, and we'll also use it later on to actually darken the base color of the metal, because as the metal ages, it turns darker, and after it turns darker, the oxidation starts to appear. So we will use the value parameter to darken it. Not that much, but just a little bit. So now we have the base color finished. So let's keep things organized. Let's keep it maybe something like this, and frame it again, and let's name it metallic base color. Okay, now we'll move to the oxidation layer. Copy the color ramp and the HSV nodes, Control C, Control V. Let's move them down. And let's plug in the base noise into the factor. And let's change the metallic value to 0 because the oxidation layer is not metallic, and the roughness crank all the way to 1. And let's plug in the result. Change the color to 0.094 on the red, 0.434 on the green, and 0.372 on the blue. Well, now it doesn't look much interesting. We have to crank out the contrast of the noise by adjusting the color ramp. So let's change the stops. The second one will be at 0.194 with a value of 0.799. Third one is at 0.353 with a value of 0.255. Okay, and this is exactly what I was after, to crank out the contrast of the noise. Now it looks nice, almost like a marble. So let's continue tuning the the color ramp farther. Fourth stop is at 0.478 with a value of 0.562. Fifth one is at 0.772 and a value of 0.363. Okay, sixth one will be removed. The last one is at full 1 with a value of 1. So now we have our oxidation layer, and let's also darken it almost in the same way like we did with the metallic base color. So let's take our crevice mask at a invert node, but not plugged into the factor, but actually into the color socket. And let's add a mix node, set it to color, multiply, and let's plug the color of the oxidation to slot socket A, and the inverted crevices masks into the socket B. Let's clearing the factor all the way to 1, and let's see our result. Now it's darkened too much. It's pronounced too much, so let's keep it at 0.5, maybe take it a little bit more. Okay, like 0.733. Looks 0.75. Okay, this looks good to me. Now we'll add some dirt to the oxidation layer. So let's copy the color ramp and the HSV node. Control C, Control V, Control C, Control V. Yes. Let's move it downwards a little bit. Change the color to dark brown, 0.023 red, 0.014 green, and 0.011 blue. And we will mix the crevices mask with one of our noises. So let's add a mix node, change it to color, mode to multiply. Let's move aside the crevices mask and also the base noise a little bit to the side. Let's select the noise texture with the higher scale, and let's plug it into a color ramp. Change the positions of the stops to 0.214 for stop 1 and 0.814 for stop 2. Plug the color into socket B and the crevices mask into socket A, and crank the factor all the way to 1. Now the result will be fed into the color ramp once again into the color ramp, and to mix the dirt layer with the oxidation layer, we will use another mix node. Again, change it to color. The mode will stay at mix. So let's plug the oxidation and the dirt, and we'll use the result of the multiply as our mask. So let's see the result. The effect will be quite subtle. Yes, you can see that it added some darkening with a color variation. Let's also turn down a little bit the darkening of the oxidation layer to 0.5. Yes, and now the noise is actually a little bit more visible. The dirt is a little bit more visible. We can play around a little bit with the contrast of the noise to bring out the dirt a little bit, but I want the effect to be quite subtle. So let's keep it like this, and again let's organize things a little bit better. So this will be our oxidation layer. So let's frame select it, and name it as a oxidation layer. Okay, so this will be the dirt layer. So let's select this one, like this, frame select it, and change the name to oxidation layer. Okay, and one more thing I want to do, I want to darken the oxidation layer a little bit more. So let's add an additional HSV node and plug it like here. It will automatically expand the frame. And let's change the value to 0.45. Now it's nice dark brown. Let's actually also change it to 0.55. I think it's too much dark. Okay, so the dirt is done, and now we can continue with mixing the base metal color and the oxidation layer. Add a brightness contrast node. Okay, let's move it bit to the top, and connect to the color our base noise. And also what will come to play is the edge mask. So let's add a map node and set it to multiply. Let's plug the brightness contrast to the bottom value and the color of the edge mask to the top value. And let's see what we have. So how this will work, we also need to crank up the contrast to 10, and how this will work, we will be driving the brightness value from say -2 when it's completely black to 4 where it's completely white, and it's actually multiplying it by the edge mask, which is black on the edges. So it's creating these let's say polished edges look. So let's unplug it, and now we can mix the base color and the oxidation dirt layer. So let's add a mix node. Okay, change it to color. The A value will be the metallic base color. The B value will be the oxidation dirt layer. Let's plug in the result to our base color, and we will use the mask that we created as a factor. Okay. Now let's set it the metallic value to 1. We'll take care of that in a moment. The roughness to 0.1, and let's see the brightness to -2, and we have our clean metal, and at 4 we have our oxidation layer. So actually let's take care of the metallic value at once. Let's add another math node. The metallic value should only be 0 or 1, unless you are trying to create some alien material. It should always be 0 or 1. We will use less than, and we will plug the result of the multiply to the value. The threshold we will set to 0.84, and we will drive the value to the metallic socket of the material, and we have our result. We just need to take care of the roughness, because the even if we have the oxidation, it's still very very shiny, the material. So let's make a little test from -2, and we can change the value to, yeah, now the oxidation starts to appear, and at 4 it's fully oxidized. So we'll continue with taking care of the roughness. The simpler part is the roughness for the oxidation layer, as it will be almost fully rough. Let's add a map range node. This takes an input value and changes it in the range from 0 to 1 to another range that you set up. So let's plug in actually our result of the color ramp for the oxidation layer as our value, and these are values from 0 to 1. So we'll keep the from 0, from minimum to 0, from maximum to 1, and we want it to be very rough. So it will map the 0 to 0.85, and the 1 will be mapped to 0.95. So it will be in a very tight range of the roughness. Okay, so let's see the result. If we plug it into roughness, okay, that's good. That's very rough. Okay, let's unplug it and create the roughness for the metallic base color. And also what I forgot was to frame the mask. So let's frame select it and name it mix mask. Okay, now let's move it a bit to the top. Okay, not this one. Oh, I don't want you to move along. Okay, now let's also make some more room for the roughness of the metal. So the metal will get progressively rough as it ages. Let's add one map range. Okay, and plug in our color ramp into the value, and this will be very subtle effect, just to add some variation to the clean metal. So let's actually set our value of the brightness to -2 to fully see the metal, and let's plug in the result into the roughness socket. Okay, that's obviously too much, so let's map it from 0 to 0.2. Okay, now we have some variation in the roughness, and we will not make it linear, we'll make it smooth step. We'll make it a smooth step. So it's a little bit more distinguished, the edges. Or no, it's actually a smooth step, not smoother step. Or step linear. Step linear looks good. Step linear looks good. And let's put here 6 steps. Okay, that looks good to me actually. Maybe change the top value to 0.15. That's, yes, just to be some variation in the material, not to be too flat. Okay, that's one roughness for the metal, and let's also add a math node. We'll set it to add, plug the result of the map range, and we will drive the value. So now actually probably would be a good time to start building the way of how we drive the values. We will add a value node. Okay, and also what we will need is another map range. It's my favorite node for this material, and we will need 4 of them. So let's Control C, Control V, Control C, Control V, and one last time Control C, Control V. Okay, one will actually drive darkening of the base color. So let's plug in the values. Or we can name it not a darkening, but the crevices darkening. Crevices darkening. Okay. Then this one will drive the darkening of the actual base color. So let's call it the darkening. Let's also plug the value. Another one will drive the roughness. Okay, like this. And the last one will drive actually the brightness. So let's name it brightness. Brightness. No, brightness. Okay, like this. And we will go from in the value, we will go from 0 to 1. So the brightness will come from will be mapped from 0 to 1 and will be mapped to -2 to 4. But what I actually want is the oxidation to appear somewhere in the middle of the range. Until 0.5, I want just the metal to get darker and rougher. So we will change the from to 0.5. Okay, and now we can plug the brightness to the brightness value. Okay, and let's actually test it out. If we have 0.5, yeah, it's working, it's driving it. And for 0.5 we still have our clean metal. And yeah, now the oxidation starts to appear. Okay, let's drive it back to 0. Okay, the crevices darkening will drive the factor of our multiply node, so let's plug it in. Okay, the result. No, once again, sorry. Okay, let's get back and plug in the factor. So uh, this will take place from 0 to maximum 0.3. I wanted 0.3 to be fully visible, the darkening in the crevices. So let's take a look. Yeah, but maybe at 0.3 to be a little bit subtle. I think this is too brutal. Let's turn it down to 0.85, 0.95. That looks good. Okay, and the darkening will actually drive the value of our HSV node. So now we have it pretty dark, but let's again turn it down a little bit, and we actually want it to be inversed. So now we have it at 0 fully dark. So we need it actually to minimum 1 and to maximum 0.25. And also let's change the range a little bit, because I want it at I don't want it to go past 0.5. At 0.5 to be already maximum dark. So from maximum to 0.5, and at 0.5 we already have it quite dark. Okay, and what we will also do, we will add some roughness as the value progresses. So at 0.5 we will add 0.3 to the roughness. So let's plug in the result to the roughness, to the add. Okay, so this should be actually our roughness now. Let's see what we have. Let's try to drive the value 0. Okay, and we are going rougher, and we are not going darker. Why is that? Did we unplug something? Or maybe we change something else? Or maybe with the progressing roughness, it's actually 0. I think it's getting darker, yeah, but it's not very visible with the progressing roughness. So we can actually fix it, I think, mm, by changing the value to a little bit more darker, to 0.15. Yeah, it's getting darker at 0.5. Yeah, that's pretty dark. So we have taken care of the metallic value. We have taken care also of the roughness value, and we have taken care of. We didn't mix the roughness actually. So let's add another mix node and plug the result to a. Also let's set it to color. Put the metallic roughness to socket A, the oxidation roughness to socket B, and now we can put the result in, and we will use the mix mask as our factor. So let's plug in also this. Okay, now let's test it out again. So we are at 0, and let's go progressively farther with the H. Okay. So there we go. We have it. We have it pretty much done. Okay, and what we will actually also do is we will add some scratches to the material with a bump map. But before, let's organize things again. So let's zoom out a little bit and frame 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 these nodes. So frame selected. Let's name it aging. Okay, and let's also move these nodes together. These are our roughness nodes. So let's frame these as well. Frame selected and name is roughness. Okay, now it's not really well organized. We could add some reroutes, but it's not that complicated setup not to really know what goes where. Okay, so now we can get to the final touch to the material, and that is the scratches. We will use a Voronoi for that, so let's add a Voronoi. Okay, and let's also add a texture coordinate and plug in the object information into the vector. We will need also another color ramp to boost out the contrast of the Voronoi texture. So let's plug in the distance into the factor and set the Voronoi texture to distance to edge. We'll keep the scale at 5 and the randomness at 1. Okay, and let's copy the two nodes of Voronoi and color ramp, Control C, Control V. I know there is a Control Shift D that also keeps the connection, but it always pops up a little bit late in my mind. So we will set the other Voronoi to smooth F1. Okay, and we will combine the two by adding a math node, which will be set to add, and the values, let's connect them, and you have to also select clamp. Let's see our result. So plug it to the all the way far to the base color. Okay, and now what we have is not what we really want. So let's, because we didn't change the contrast and the color ramp, so let's turn down the contrast on the distance to edge all the way to the left. It will create quite fine lines, even farther. Okay, like this. And the color ramp of the smooth F1 Voronoi, we will turn down the white value, which will mask some of the connecting lines. So now we have some of the scratches, and to make it a little bit more interesting, we will duplicate the two. So let's put Control Shift D, and it doesn't work with me because I don't have the default Blender shortcuts. So let's Control C, Control V, and we will replug it. Okay, and we need a bit more space for it, so let's move it entirely here. Okay, object vector. Okay, it's not too much of a hassle because it's quite fast. So let's change the scale to 23.5. The same will be at the other one, 23.5. Okay, and let's also copy the math node, Control C, Control V. Okay, and plug in the colors. Okay, and add a mix node. We'll plug the first value. Also, we have to set it to color, and the mode will be darken this time. So let's add a value here, the second value here, and let's see the result. Okay, ooh, all the way to the right to our base color, and we have some long scratches, and we should also see some short scratches, but I don't see one. Let's actually do something with the smooth F1 Voronoi with the larger scale, and let's pop it out a little bit, just like that. Perhaps yes, there are appearing some. So we have one here. We have something here. Okay, there are some. They will be more visible when we add the bump map. So let's actually separate the connection and add a bump map. What this does, the node, is that it converts a black and white input data into a normal data that we can plug into the normal socket of our shader. So let's do this, and let's plug it here to the normal, and now it's appearing. Okay, so let's also change the base color because we unplugged it previously, and let's get back to our bump because we need to tune it a little bit. That's too brutal. That's too brutal, and also we have to fix the shorter scratches because they don't look the way I want them to look. So let's work out something. Yeah, this is what it masks out. And we are working on the shorter one, but also we need to tune up the long ones. So let's mask them out a little bit more, just to be quite subtle, not that not that brutal. Okay, and let's also change the parameters of the bump map. At this point, we have the distance set at 1 unit. That means in my case 1 meter. You might have different units like feet or inches, but anyway, this is too much, and we will set it to something like 1 millimeter. That means 0.01, and now we have the scratch is pretty subtle. Also, maybe turn down the strength to 0.5. Yes, and that is now our scratches. And also, what I want to do is when the oxidation appear to be little bit pronounced by the bump map. So we will again mix the two colors of the scratches and of our mix mask. So let's move aside the bump node, add another mix node. Okay, let's change it to color, and we'll plug it. Oh no, once again we'll plug it here. The result will go into our hide map, and the mix mask will come into the slot B. Okay, we don't see much here because it's actually all black. Let's change it to multiply. Factor we can keep at 0.5. I don't want it to be too pronounced. So let's now actually change our value to something when the oxidation starts to appear. And that is here. Yes, that looks pretty good. It seems to be pronounced a bit, and the scratches are also visible. So let's drive it all the way to 1. Okay, now we have it pretty much done. So this is our oxidized bronze material. The last thing I want to address is rendering in Eevee. The shader will work, but it will miss the crevices, dust, and the exposed edges. There's a way to go around with it. But, let's first frame the scratches. I forgot to do that, so let's frame it. Let's rename it scratches. Okay. And now let's disable our preview. I want to speed things up a bit and change the renderer to Eevee. Okay, so there's a way to go around with the exposed edges and the dusty crevices. That's with an ambient occlusion node. So let's search for ambient occlusion. It works also in cycles, so we would have an universal shader, but unfortunately, the Blender manual says that the ambient occlusion is very computational heavy for cycles, and that's why I decided not to use it and to go with the pointiness. Uh, let's add a diffuse shader to see the effect of ambient occlusion. Let's add a color ramp. Let's plug the ambient occlusion to the factor, the color to the color, and let's plug the result into our material output. So let's go here, okay. And also, what we have to do in order for it to work is to enable the ambient occlusion here in the render tab for Eevee. So let's go to our preview. We have to wait until it compiles the shader, okay, and we have to boost out the contrast. So for the edges, we actually need to enable the inside check, have only local, and set the distance to 0.05, something like this. And now let's play around with the contrast, okay? And we have what we wanted. It looks a little bit different than the pointiness, but we are, yeah, now we have it. Now we have it pretty much the same effect. So let's also crank up the samples to 32 for it to look better. Yeah, this is our edge mask. So we can unplug it and plug the color to factor, and let's duplicate it. Control C, Control V. Now Control C, Control V. Okay, let's see what it looks like. Let's check out the inside. Change the distance. We can keep the distance at 0.05, but let's actually switch the or crank up the. Yes, this is what we want, but I think inverted actually. So let's turn the color ramp around. And maybe we'll have to increase the distance to actually get the effect to 1. And now we have our crevices. Yes, this is it. There is bit of a problem though with the ambient occlusion in Eevee, and that is it's like the screen space reflections. It's a screen space effect. So if you go outside of the screen, you can see the effect changing. So at moving objects, it can look a bit weird. For static objects and for static camera, it's okay. So let's cut the connections here and move it to our crevices mask. Okay, let's plug it inside. So let's plug the color to the factor. Okay, here it's already plugged in instead of the geometry, and let's enable the shader. So this is it in Eevee. Yeah, it looks good as well, doesn't it? So if we play around a bit with it, yeah, it's not as sensitive as the. So this is it. We have our shader also working in Eevee. And what we can do is to make the shader really universal. So the user can switch between cycles or Eevee as he wants. So let's copy everything. Control C, Control V. Let's move it down, and let's disable the preview. So The top one will be for cycles. Let's delete here the ambient occlusion. Let's replug the pointiness. Okay, the same for the crevices mask. Okay, and the bottom one will be for Eevee. So let's select Eevee in the material output, and here we will delete the geometry and insert into the frame the ambient occlusion. This and the same for the crevices mask. Okay, and now we can test it out. So we have Eevee as our renderer. Let's turn on the viewport shading. Okay, it's working in Eevee. Let's also delete the diffuse BSDF that we used for the preview. This one as well. And now we can switch to cycles. Okay, it works like a charm. Let's turn down the samples for the viewport for 32 and for the render for 128. We will not use it, but that was my setup when I rendered the intro. And also what I want to do is to tune up a little bit the edge mask for the cycles. I've had a little bit more grungy in my intro, and that was just by turning the sliders a little bit to the left and exposing the edges a little bit more. Okay, that's too much probably. Something like this. Yes, that looks good. Okay, so this is our final shader, and that's a wrap for today. So thank you for watching, and I'm looking forward to see you at my next video.